Okay, hi, this is Roderick Lees doing the 2016 SQA National 5 Mathematics Paper 2, and we're going to be doing question 1 to 8. Okay, and here we go. Question 1. A drinks manufacturer is reducing the sugar content of one of their fizzy drinks by 8%. How do you reduce something by 8%? Well, the quick way is to multiply by 0. And then think of 100 take away 8, which is 92. So that's your multiplier to reduce 8%. You multiply it by 0.92 over 3 years. So the sugar content of a standard can is currently 35. How do we reduce it by 8% over 3 years? We multiply it by 0.92 to the power of 3. And we get your calculator out. And you should get 27.25408. As you can see, I've rounded that off a bit. And I'm just going to round that off to one decimal place, 27.3 grams, and that's to one decimal place. Question 2. A pollen sample weighs 12 grams and contains 1.5 times 10 to the 9 pollen grains. Okay, find the weight of one pollen grain. Well, it's the weight of all the sample divided by how many pollen grains are in it. That will get you the weight of one of them. So it's 12 grams divided by, and obviously this is just a use of your calculator, 1.5 times 10 to the 9, and you get 8 times 10 to the minus 9 grams. On to number 3. Okay, question 3 was a reasonably simple vector one. The diagram shows the parallelogram ABCD, and you can see that A to B is vector U, B to C is vector V, and express how you'd get from B to D in terms of U and V. Well, how you get from B to D, you would go from B to A, and then from A to D. Now B to A is the opposite of vector U, so that's minus U, that's the opposite, and A to D is vector V, because that is exactly the same movement as that one there. Okay, so that's V, so it's minus U add V, and incidentally that's the same as V take Q, that's hopefully correct also. Okay. And question 4. Reasonably simple difference of squares. Factorise fully, it says, so you can take out 3 as a common factor, so that's it, factorised to an extent but not fully. 3x squared take 3 16ths 48, and x squared take 16 is a difference of squares. X times x gives x squared, 4 fours give 16, minus, plus, there we have it there. Question 5 is the angles in a circle sort of a question. The diagram shows a circle centre O, and you can see that, let's just work out, let's see what they're telling us. A to B and C to B are tangents. So that means that this line here that I'll talk about later on, that's 90 degrees, and this line here from the circle to the point where the tangent meets, there's your tangent line, that's 90 degrees as well. And AOD, so A to O to D, so that angle there, kind of messed it up a bit, but there, that's 143. Now with this being a straight line, that leaves 37, okay? So 180 take 143 leaves 37. I would use a calculator for that. Now, what have we to get? We have to get that size of angle ABC, and that's the massive shaded one we have over here. Okay, so let's just work our way through this. That's 37 because we took it away from 143. You might remember the Z rule. That makes that 37. I talked about that being 90 degrees. 90 take 37. That makes that 53. Okay, now why is this one the same? Well, from there to there is a radius. From there to there is also a radius, so that makes this an isosceles triangle. So if that's 37, that's 37. I mentioned earlier on that that was a right angle, same as the one over here. That makes that 53. 53 and 53 is 106, and all the angles in the triangle add up to 180. So 180, take away 106 using your calculator, or that's quite an easy one, is 74 degrees. On to question 6. Okay, one of the ones you can absolutely bet on. It's a standard deviation question, and Jack called his internet provider on 6 occasions to report connection problems. On each occasion he noted the length of time he had to wait before speaking to an advisor. Okay, there we have it there. 6 calls, 6 times. Calculate the mean and standard deviation. So you really should have practiced this again and again for this paper. The mean, add them all up and divide by 6. 78 divided by 6. Again, use your calculator almost all the time. That gives you 13. I'm going to use the first of the formulas for standard deviation. That's the one we used almost all the time. That's the one there. Okay, and here we have it here. So these are all your x numbers written there. That's just these ones there. These ones there just written in a column. Here we're going to do each number, take away the mean, and then square your final answer. So 13, take 13 is nothing, square it, you get nothing, of course. 16, take 13 is 3, square it, you get 9. And you can see all the way down, we have it 22, take 13 is 9, square it, you get 81, so on and so forth. So when you add up all these, okay, you get 164. So that is the sum of each number take away the mean squared. So that is that number there. So that gets replaced with 164. N take 1, there's 6 numbers, take away 1, you get 5. 164 divided by 5 is 32.8, and the root of 32.8 is 5.7, and I've rounded it off to 1 decimal place. And just reiterating what the mean was, it was 13 minutes. Okay, perhaps predictably, you've got a conclusion to draw from another situation. Sophie also called the same internet provider to report her connection problems. Her mean waiting time was 15 minutes and the standard deviation was 4.3. So make 2 valid comments. Well, Jack's mean waiting time was 13 minutes, Sophie's is 15. So one fair comment is to say that his average waiting time was 2 minutes less than Sophie's. Now because, and so that's the mean being kind of alluded to, we'll now talk about the standard deviation. As Sophie's standard deviation was less, that means that her numbers were kind of more consistent. Her waiting time was a bit more predictable, okay, but consistent is the word you would want, okay. Her waiting times were more consistent. Okay, let's go on to question 7. Okay, a carton is in the shape of a large cone with a small cone removed down at the bottom. Okay, so there's your carton, maybe a kind of ice cream kind of carton there. And there we have that cone taken away, and this leaves the space here. Calculate the volume of the carton, and we'll have to give your answer to 2 significant figures. Okay, that's important, it's bold, it's important, and we'll talk about that later on. Okay, right, well the volume of the carton is the volume of the large cone. Take away the volume of the smaller cone there. So it's 2 lots of that formula there. You would look at the formula sheet to remind yourself what the volume of a cone was. It's 1/3 pi r squared h. So at the top cone, it's 1/3 times pi times half of 32, 16 squared times 24. So there's your first larger cone there. Take away 1/3 times pi times, that's 18, so that's 9 squared times 13.5, and there you have it there. Okay, you get the calculator out. For each of these I kind of chose 3 decimal places because it seemed easy enough to do. So that one there came at 6433.982. This one came out at 1145.111. Do your subtraction, and don't forget it's said to 2 significant figures there. There it is there. Okay, so in order to show that you know how to do this rounding off, you've got to write down the number that you rounded off to. Here it is there, and let's do the rounding off. There's your first, there's your second, there's the third, that's your third significant figure. This one has to be done to 2, so that number may become a 3 or not, depending on what the third significant figure is. That rounds that up to a 3, so it's 5, 3, and all the other numbers turn to 0, 0, 0, 0.000, there it is there, 5300 centimetres cubed to 2 significant figures. And number 8, okay, you have the step ladder, and obviously just focusing on the diagram, you can very well guess that the question is find the size of x. Okay, so this is a sine rule question. A over that over sine that is that over sine that. So 150 over sine 66, 150 over sine x, pardon me, is 140 over sine 66. Cross multiply your way out, and that gets rid of the denominators there. So 150 times sine 66 is 140 times sine x. Okay, now that means that sine x is 150 times sine 66 divided by the sine of 140, which gives you 0.979. Do a shift sign on that, and that gives you 78.2 degrees.